Limiting factors. In this video, scientists will be able to comprehend that populations will grow until their growth is restricted by a limiting factor. So here's a question you might have asked yourself. Why aren't there unlimited animals? Like, why aren't there a million polar bears or a zillion lions? Well, if a population had unlimited resources, then that population would never stop growing. The graph of the population would look like the one you see on the left. It would start initially small, and then that population would grow and grow forever as long as there was unlimited resources. However, populations do not grow forever. Eventually, a population will reach a maximum size, and that maximum size is what the environment can sustain. That's based on the resources that are available to the population. This population that the environment can sustain is called the carrying capacity. On the graph on the right, you can see that the population grew initially until eventually it reached a spot where the environment can no longer sustain any more individuals of that population. So the population would stop growing and start becoming more constant. That limit that the population reached is called the carrying capacity. Now, what causes a carrying capacity to be reached? Well, there are things called limiting factors. A limiting factor is anything, so this might be biotic or abiotic, that can cause a population to slow or stop growing. Again, on the graph on the right, you can see the blue line for the population quickly grew until it reached its carrying capacity, and then limiting factors, which could be living or non-living, would cause that population to slow or stop growing. Some common limiting factors can include access to food. If a population has more food, it'll have a higher carrying capacity. If there's less food, it'll have a lower carrying capacity. Predators can also impact the population. More predators means less of the population. Less predators means a bigger population may be able to exist. There's also the issue of space. For example, aquatic animals living in a pond, there's only so much water that they can live in, so the population would be limited based on the space available. Access to mates can also be an issue. And finally, there can be changes to the environment. Changes to the environment could impact both the biotic and the abiotic factors. So what does a general population growth graph look like over time? In this graph, we're starting in the early years. The population, let's say, just moved into an area. And the first thing that would happen is the population would grow very quickly. A new small population would quickly expand because there would be plenty of resources. Eventually, however, the population would become limited by resources. Maybe that population would run out of food or run out of space. At that point, the population would stop growing. And if nothing else changed, that population would find its carrying capacity. There would be roughly a certain level of population that the environment could sustain, and the population would hover around that carrying capacity if nothing changed. But what happens if there is a change? Well, keep in mind that limiting factors can affect populations. So if there is a change to the environment, that can change the carrying capacity of a population. Again, some common things that can cause changes might be the introduction of a new predator. If a new predator comes in, then the population that it eats would naturally be lower because the predator be eating more of them. Or if a new animal that competes with the population moves in, well, then they're fighting over the same resources, and the population that is competing would be lower because they would have less access to those resources. Or finally, there could be a loss of habitat or food. Let's look at an example. In this graph, we'll be looking at the populations of deer and plants. So again, let's pretend that deer move into a new area. Their population would be small, and they have access to a lot of plants, which is their food. As you would expect, the deer population would grow quickly. They have access to a lot of their resources, so their population could expand. The plant population, because there's a new predator, would decrease. Now, if nothing changed, you would expect that the deer population and plant population would find a natural carrying capacity. The populations would stay about the levels they are. But what happens if a storm comes through and destroys a lot of the plants? Well, in that case, if the habitat is damaged and the plant population decreases, then there is less resources for the deer, and the deer population would decrease. Since the plant population was decreased, now there's less overall food for the deers, and over time, the deer carrying capacity would be lower than it would before the habitat was damaged. So again, most of the time, populations reach their carrying capacity and stay that way. However, if there's something like habitat damage, or new competition, or a new predator moves in, that carrying capacity can be raised or lowered to a new normal.